For day-to-day use of compass, the work that was demonstrated in the previous setup videos is not required. When we run a calibration, it's simply a process of going through initialization selections of selecting what's going to be calibrated and how it's going to be calibrated and verifying the remote interfaces. This video puts all the work of the DUT definition, support device definitions, and test definitions into play to show how a normal calibration is handled. To run a calibration, we go to the Run menu, choose Run Test Definition. Alternately, clicking the play button does the same thing. And the test will start off with a series of screens prompting you to tell the software what's going to be calibrated and how it's going to be performed. So I'm going to start here by clicking Clear Previous Selections. This will clear from memory anything that was previously calibrated along with those instruments. So I'm going to run this test in PSI. Just hit PSI. I'm going to type my name in here. And this information will be recorded to the data file. Just put Matt. And next. And I'm going to calibrate my Ashcroft K17. From my list, I need to bring it down into the selection window. I double click and it brings it down into the window. If I had the ability to do 2 or more of these, that would require a multiplexer, but if I had that ability, because the Ashcroft is configured as a profile, I go up and select it a second time and Compass will ask me how many devices do I want to run. Well, I could run 2 of these or more. So if I say 2, this is how we're notified that we're going to be running 2 of the Ashcrofts. Well, that's not the case, so I'm going to double click to delete and double click to select once. One sensor, click next. Now this is where Compass requires the unique identifier such as a serial number or an asset. The Ashcroft was configured as a generic profile. This information was not provided during the setup. It is required at this point. So I'm just going to use a simple serial number of 111 and that'll meet that requirement. Compass knows it has a min and max of 0 to 30 psi and calibrated engage mode. My responsibility is to make sure that my current source, however, is selected. If I keep it blank, this isn't going to play well with Compass. So from the drop-down menu, I choose my Fluke 8846 to measure current. Next. Now what test definition? By default, it auto-selected 25% up and down. This was made possible because under the DUT definition on the calibration tab, I assigned this particular test to be used when this DUT is selected. So this greatly simplifies my responsibility at this stage. Next. Oh, and by the way, if you are curious about what this test looks like, you can always highlight and then click View, and this will bring up a view window. All options are grayed out. You can't make any edits, but it will let you see what points are going to be tested and what standards to be used. All right, next. It auto-populated that I will use the PPC4 for the reference pressure and for the control. If I wanted to throw in, and if I had support devices to measure my ambient conditions, I could do that, or I could always just do manual entry. For this test, I'll just go N for none. I'm not using a multiplexer and I'm not using any valve drivers, so next. So now we get into the next couple of screens where Compass will establish communication with our meter and then our PPC. Your responsibility at this point is to make sure that you've got the correct COM port configured. If this is wrong, click the white space and make the changes. Everything looks good, so I'm going to hit next. Alternately, if I look at my min and max value, this is just showing the capability of the meter, not of the DUT, but if I needed to make a change, I could always go to Customize Output and change the scaling. But this looks good the way it's configured. Now we have configured device 3 of 3. It's the PPC4. It has a serial number. These fields are grayed out. I'm pretty sure that the COM5 port is what I want. So if I'm correct, I can hit load settings and it'll start reading back the information. If I'm wrong on the COM port, Compass will try for 5 seconds and tell me that it can't communicate. At that point, I'll just go back and click on the COM port selections and make sure that things are matching between Compass and the PPC. And here, because of the auto detect feature and the auto scale capability of the PPC, Compass is defining an auto range of 0 to 30, which matches the span of the Ashcroft sensor. If I were to make a fluid head correction, I could put in a height here. From the video, these are roughly, probably about 5 centimeters below the PPC. And in Compass, the sign convention is if the device under test is below the calibration standard, it's a negative height. But given that the tolerance of the Ashcroft is plus or minus 1%, I'll never see a 5 centimeter head, let alone something much larger. So I'm going to just, out of convenience, keep that at 0. And I've got nitrogen gas as my medium. This looks good. I'm going to hit next. And we have a final confirmation screen. Just make sure that this is the test that I want to run. I've got one DUT with this min and max pressure, and my pressure standard matches the DUT. This looks good, and finish. So when we hit finish, we begin to initialize the test. We have windows that appear. These windows can be moved and resized without influencing the sequence of the test. We've got our control toolbar at the top, and at the bottom, perhaps a more critical stage is the status bar. The status bar tells us what operation is executing and at what stage it's at. So we're currently testing the pressure. We're taking a data point and we're averaging the data, and we've got about 10 seconds remaining on the average. On my PPC4 window, it tells us the measured pressure, the target, and my stability and hold limits. The window can be moved. It can be resized. If you don't see the window, it's possible that it just needs to be opened. For example, I can close this, and on my toolbar, we can click on this button and it shows all of the devices that are being used. The DUT, the pressure controller, and the meter. So here's my PPC4. Just simply click that, opens the window again. My DUT window is over on the right hand side, and it has two lines. The bottom line is the raw or the native output. The top line is the corrected final output. It's really not corrected so much as it's just simply converted from a milliamp to a pressure value. Compass will log both data values. And if you don't want both data values logged, you have an option to only log one or the other, or neither, if you so wanted. Those again are under the Tools menu, Options. On the right hand side of this window, we have a little drag bar that can be used to scale the size of the font. I've got a data plot. So the data plot can be turned off and reopened through the plot window button. From the drop-down menu, I can choose different types of plots. New, fresh installs will only have about 6. It looks like they'll probably have these 6 standard plots that we can use. The plot tool allows you to create custom plots, and within Compass you have the power, although it might not make sense, you have the power to create a plot where you plot any parameter against any other parameter. So if you want to plot a piece of data but you don't see it in this drop-down menu, when you're not running a test, simply go into the plot editor tool and create a custom plot. I'm going to choose percent span error versus reference pressure. So this dark blue line has the 3 dots. We're on our third pressure point, or we just logged our third pressure point. Compass logs the dots and then basically connects the dots with lines. Below this, we see a dashed green bar, and below that, a second dashed green bar. These are the upper and lower tolerance bars. So our as found results for this DUT is that it's out of tolerance. It has an offset error of roughly just shy of 1.5%. So we will have to turn the little potentiometer to adjust to 0 before this gauge goes back out into the field. And on the bottom we have our data grid. The columns that are shown are user selectable. You can turn on and off columns showing only the data that's pertinent to you, or you can show everything. But we've got a scroll bar that lets us scroll across. And here's statistics on the DUT. We have the DUT min and max, standard deviation, and the samples. So scroll back a little bit, see if I can put this all in one window. I can't right now, but we have the DUT average pressure value right here. The native output of 4.22 milliamps. Scrolling across, during that 15-second average, I was able to collect 48 samples. The min and max pressure and the standard deviation on that. So what we can see is relative to the resolution of the DUT, we have a very stable pressure. I can scroll further to the right and get similar statistics on our reference. Our reference min, reference max, standard deviation, and number of samples. And here we can see with greater resolution that we do have a little bit of fluctuation on the pressure. What I'm looking for is to make sure that there's not any particular point that has a large standard deviation and subsequently a large difference between its min and max pressure. If that's the case, that would suggest to me that the pressure either was not stable or perhaps part of the data stream coming back to Compass was lost or damaged. These numbers look good. And one more note to point out. From a statistical good practice point, for an average to be considered confident, good practice says you need to have 7 or 8 samples for an average. Here we have 13 and 14 and 13. That is good. If one of these test points had, say, 6 or 5 samples compared to the others having 13, that would also suggest a problem. Typically that would fall under an issue with the computer's processor or the remote interface tool. So a few things to keep your eyes open for while running an automated test. Okay, I'm going to pause the recording, and when this test gets closer to completion, then we will resume.